Good morning, everyone, or good afternoon or good evening, as the case might be, depending on where you're located around the world. My name is Martin Tingley. I work on the centralized experimentation platform at Netflix, and today I'll be talking broadly on the themes of democratizing decision-making and experimentation at Netflix. And we'll hit on this theme of democratization 3 times throughout this talk, and we'll summarize them at the end. First, how we make decisions. Second, what we try in our product experience. And then third, how we scale this process throughout the company. So to kick us off, let's go back in time about a decade to 2010. This is what the Netflix television application looked like at that time. Pretty primitive user experience from today's standards, pretty static, some limited interactivity. Just generally looks pretty dated at this point, but it served us well about a decade ago. So let's fast forward to today, or almost today. This is basically the current state of our TV application. It's a much more video forward experience, a much richer, more immersive experience, a lot more interactivity, more efficient use of space. And overall, we'd like to believe a better experience for our members. So the question is, how do we make all of the decisions required to take us from that static, primitive experience from a decade ago to this video forward, more immersive and interactive experience that you'll find on the Netflix TV application today? So how do we make the right decisions to evolve the product? And this extends beyond the UI. This extends to everything we think about when it comes to the Netflix product experience. Well, there's a lot of options on how we might make decisions as a product organization in Netflix. We could ask a HIPPO. A HIPPO here stands for highest paid person's opinion, right? Just say, hey, whoever's making the most money in the room, we'll let them decide. They must know best. We could hire a bunch of experts and just do what they tell us. Some great graphical designers, some great UX designers, great product managers, all of that. We could just have a giant debate within the company about what we should do. And maybe whoever's persuasive, most charismatic during that debate, maybe their opinion will carry the day. And more these days, being a streaming video on demand service, we could simply copy the competition. We all know there's enough competition out there that we could copy at this point. So of course, it's a trick question. We don't do any of these use any of these as the basis for decision making. Instead, we A/B test every idea before exposing it to all of our paying members. So what is an A/B test? Very simply, we take our Netflix members, who we always hope are happy and dancing, and then we take 2 versions of our product experience, version A, or the control experience, and version B, the test experience, the treatment experience, you'll hear it called as well. And here the difference is that middle row of images. Version B introduces this mobile preview experience, which you can now find on our mobile app. We take a subset of our members, divide that subset into 2. One subset, one random sample gets version A, one sample gets version B, and we expose members to these 2 different experiences, and we compare some business outcomes. This is the basic framework of a test. Later on in this talk, we'll go into a bit more of the technical details. Okay, so why does Netflix believe in experimentation as a way to make decisions? Well, simply put, it's our belief that experimentation enables us to make better decisions about how to evolve our service, so ultimately we can deliver more joy to our members. This really is about maximizing the value of the experience we give to our members. And we believe experimentation is the way we can do this well. And this brings us to this first democratization theme. A/B experimentation scales, and by that I mean many members are voting on proposed experiences. If we think about these different paradigms we could use to make decisions, starting with the HIPPO over there, and which is one person, and ending on the far right with millions of voices getting to contribute to that decision, we start mapping some of these decision paradigms onto that. If Netflix were to rely on the HIPPO, internal experts, group debates, maybe somewhere between 1 and a few thousand voices max would participate in that decision-making process. we were to do qualitative customer research, somewhere between hundreds, maybe tens of thousands. With A/B experimentation, we can reach a lot more people. We can run very large experiments at the scale of Netflix. We can really democratize the input to that decision-making process. We can give each of the members in that test a vote on how we should evolve our product experience, and they vote with their behavior. If one of these product experiences leads to more engagement, we'll conclude, hey, this is a great thing for our members. It's allowing them to derive more value from our service. So that's democratization theme one, how we decide. We use A/B tests, and really that means we allow our members to vote with their actions on how to evolve our product to deliver more joy. Okay. So whenever I talk about A/B experimentation in groups like this, one of the questions that comes up is, why not just roll out a new feature to everyone and just measure what happens, right? Take the data before we roll out that feature, take the data after that feature, and see if there's a difference, and use that to conclude that this new product experience is good or bad. So let's talk about what could go wrong if we do that. And we'll use kind of a simple toy example to illustrate. So on the left, we have our current product experience. We'll call it product A, which uses standard box art. You can see on those bottom two rows. And product B uses upside down box art. Someone has this idea, hey, if we use upside down box art, we'll increase engagement. That's the driving hypothesis behind this test. And as an outcome metric, we'll look at something like streaming hours, just general engagement with the service. Okay, so say we just roll out that new upside down box art product experience, product B, and say we roll it out on December 21, 2018, very precise date. And this is the data we collect. Blue, that product A, the regular box art. Red, that product B, the new upside down box art. And wow, look at that, engagement metrics spike when we roll out that new experience. This looks great. Okay. So the question for the room is, based on these results, would you roll out this product experience with upside down box art? On the one hand, when we think about intuition, we think about design, this is a pretty terrible experience. But on the other hand, we have this data that suggests, hey, engagement spikes when we roll this out. What should we do? Well, of course, it's a trick question. And the issue here is that correlation tempts us to infer causality when perhaps no causality exists. So it turns out that Netflix launched the movie Bird Box on the same date of this hypothesized experiment about launching product B. Bird Box was a pretty big hit for us, drove a lot of viewing. So the challenge now is we don't know why streaming hours spiked starting on the 21st of December. Was it this new product experience, or was it this big film that launched? And you might say, well, just don't launch your new product experience on the day a big movie comes out. And the challenge there is we don't really know what movies are going to be big. There's stuff we can't control. There's always what we call confounders kicking around in the background. So instead, if we had run a test and had these two product experiences, the regular box art and the upside down box art, running in parallel for different members across the launch period of Bird Box, we might see data that looks like this, where, yeah, basically every day that product A, the regular box art, results in more engagement than product B. And then when Bird Box comes out, both of these experiences see increased viewing that we think is probably caused by Bird Box, not the product. So the point here is because we've now randomized the assignment, because we have these two product experiences running in parallel, we can really conclude that product A is what is causing the higher streaming hours. It's not Bird Box, it's that different product experience. And we've sort of controlled for the presence of Bird Box by comparing engagement under these two product experiences. Okay. So that's why we run experiments rather than just roll things out and do what you might call a pre-post analysis. So what's interesting about experimentation, certainly at Netflix, and I believe this holds more generally, is despite having expert colleagues in all kinds of disciplines who generate, explore, test, experiment with tons of creative ideas to improve our service, most experiments do not win. We have a lot of ideas, and most are not successful. It's a relatively small fraction of experiment where you see that light bulb really going off, and our members, through their actions, saying, "Hey, putting up my hand here. This is a great new experience. Roll this out to everyone." Most things are either flat or just a negative experience, and by running experiments, we actually let our members tell us which of these potential product experiences are good. And this brings us to our second democratization theme, which is the democratization of ideation. Because we are in this environment where we will test any proposed product change, and because most proposed product changes are actually not winners, there's a real hunger and thirst for new ideas. How can we make this product better? What are we missing? What do our members want, etc.? And as a result, great product ideas can come from anyone. Yes, many come from our product managers, from our designers, but we also see user-facing product innovation ideas coming from engineers, from scientists, from executives. And because so many of our ideas don't pan out in tests, there's a real opportunity to sort of put your hand up and say, "Hey, I've got an idea," and all you've got to do is convince someone to test it, and we'll see. So experimentation really permits for the democratization of ideas about what to try. Because we test, and because most ideas are not winners, product innovation ideas really can come from anywhere. I've seen many a memo at Netflix where the product manager in charge of that part of the experience notes, "Hey, the original idea here came from an engineer or from some other type of function." So the marketplace for ideas is really super open once you move to experimentation. It's kind of like an ego-free situation when it's done well, because it's less about who has what title and more who has an idea that we think is going to work, we hope is going to work, and then we test it out on our members and let them help us decide. Okay, so what we're going to do now is take a little bit more time to go through how an experiment works, some of the technical nitty-gritty, and then I'll talk a bit more about what my team does at Netflix, and that will bring out this third theme around scaling experimentation. So experiments all start with an idea. We have on the left our current product, and on the right we have a new idea for the product. Here again, it's this mobile previews experience. You can sort of click into this. It will expand to a vertical trailer, and you can swipe through the trailer as sort of a richly immersive video-based experience. So we have this idea that this mobile preview product feature is good for our members. What we need to do is convert that into a testable hypothesis and identify metrics that will help us determine if it is in fact an improvement for our members. So the way we think about this is if we make change X, add that mobile previews experience, it will affect member behavior in a way that makes metric Y improve, where we can measure metric Y. So in this particular experiment, the hypothesis was something like presenting a row of short previews will increase awareness of these titles and make it easier for members to find something to watch, increasing our core engagement metrics. So there's this nice causal relationship. Members will engage with this row that will help them find stuff to watch, and as a result, we'll see more engagement. We generally spend time thinking about if experiments are even worth running. So some questions you might ask is, would you release or not release this feature regardless of A/B test results? So certainly anything to do with account security, we will roll out rather than test, because we just want to keep those accounts secure. Same for things potentially like parental controls. Just doing that is just the right thing to do. Second, we think about if the potential results will actually be meaningful to our business and when it will really deliver more value to our members. And if not, we might say, hey, why are we spending our time exploring these sort of product innovation ideas? Why don't we do something more impactful? So in the case of that mobile preview experience, it is a new feature. It sort of differentiates us a bit. And the underlying hypothesis is one that is directly relevant to our business, will increase engagement. Then the third part is it even possible to validate the hypothesis through an experiment? Is there like a super well-defined causal relationship? So in that mobile previews experiment, really was like, we'll add this feature, folks will engage with it, you'll help them find something to watch that will improve these core engagement metrics. So a very well-defined set of causal relations there. If all those questions turn out the right way, we'll run the experiment. Again, we take our Netflix members, you'll hear this referred to as the target population. We'll take a random sample from that target population, divide it into 2 buckets. Each of those buckets will get a different experience, version A control, version B test. Then we'll compare business outcomes. So that's the statistical analysis of metrics. And critically, we hold everything else constant across these 2 experiences. Any big content release will impact both control and test the same way. So when we compare control and test, we still have sort of a valid causal read. Okay, so we run our test, we gather a whole bunch of data, then we have to analyze the results. And in this case, when we compare the behavior of members who saw the new previews experience with those who saw the original experience, we found, based on our metric hierarchy, our internal metric hierarchy, that our primary metric didn't really move, our first secondary metric didn't really move, but our second secondary metric saw a statistically significant improvement. And this is the evidence we use to conclude that this was a good experience for our members. So let's take a little bit of time to talk about and build intuition about the statistical terminology and concepts we use to help manage and understand uncertainty with A/B tests. To help us do this, we're going to come back to that age-old question on the internet. How do you identify photos that have cats in them? Okay, so here we have a photo of a cat and a photo of a not cat. And there's 2 ways to correctly identify if a photo has a cat in it. The photo with the cat can say, I am a cat, and the photo that is clearly not a cat can say, I'm not a cat. So the language you'll hear is this is a true positive, a sort of a positive identification of something that's actually a cat, and a true negative, the correct identification of something that's not a cat. And likewise, there's 2 ways to make an error. The cat can be mislabeled as not a cat, and the not a cat can be mislabeled as a cat. So we call these a false negative. We failed to find that cat, and a false positive. We claim we find a cat when we didn't. So there's 4 possible outcomes, 2 ways to make the right decision, and 2 ways to make the wrong decision. And these same core ideas show up when we think about the results of A/B tests. So to illustrate, suppose we saw a 1% increase in our primary metric in our A/B test. This result is still uncertain. It could be a false positive. You'll also hear this called a type 1 error. So what does that mean? It means in the context of that experiment, we claim there's an effect from the experiment, from this new product feature, but really there isn't. So it's sort of like that not cat being identified as a cat. And likewise, suppose we saw no change to our primary metric in our A/B test. This result is also uncertain. It could be a false negative. It could be, in the language of our example, it could be that it actually is a cat and we've just failed to identify it as a cat. So here, we don't think there's an effect due to our product intervention, but in reality there is, and we just haven't identified the existence of that effect. So this second type of uncertainty, this type 2 error, or that rate of false negatives, there's sort of 3 levers we have to help quantify and manage and mitigate that uncertainty. The first is effect size. And by effect size, I mean the difference in the metric value between the control experience and the test experience. And the core intuition here is the larger the difference in the metrics between these 2 experiences, the easier it is for us to correctly identify that there is a difference. So it kind of reduces that false negative rate. So in the context of product innovation, one of the things my team will talk about is if you're going to test an idea, push the limits a little bit. Test big, bold ideas. If you have a hypothesis, and this is not a great hypothesis, that increasing the size of the Netflix ribbon logo will increase engagement, don't just increase it by a little bit, like really max out the size of that logo in hopes of getting a bigger difference between your control and treatment experiences, so we can have a better chance of correctly identifying if there is a difference. So larger differences lead to easier, more reliable detection. Second is sample size, basically the number of members we put into each test cell or test experience. And here, larger samples lead to easier, more reliable detection. It's just the more people we put into tests, the smaller the effects that we can correctly identify. So we talk a lot internally, how many people, how many members should we use in this experiment, given the type of effect sizes that we expect. And then the third, which is something my team does a lot of work on, is to think about variability. How disparate versus consistent are the metrics among the population participating in the experiment? So in the context of Netflix, we know some of our members are super heavy streamers, super high users of our platform. Some are far lighter users of our service, and then there's a bunch in the middle. So we can shift our thinking from, hey, let's just look at all of our members in the control experience, all of our members in the treatment experiences, and compare some average, to like a modeling approach where we say, okay, not all of our members are the same going into this experience. Some are heavy streamers, some are light, some are medium. Let's look at changes in each of those buckets. So those sort of statistical modeling approaches can help us reduce variance and help us with reliable detection. And we use these three knobs to reduce the occurrence of these false negatives, where again, your little mental image of the false negative is the cat saying it's not a cat. And in the stats parlance, this is called statistical power. Statistical power is the probability that we correctly identify true effects. We aim to be able to correctly identify those true effects most of the time. And then second, we need to choose a tolerance level for these false positives. So we just talked a little bit about false negatives and power. Now we have to talk about false positives and significance. So we measure statistical significance, and we accept that in general, about 5% of the time, statistically significant results are just noise. So this is that magic arbitrary 5% number. If something has less than a 5% chance of occurring through chance alone, then we'll sort of say, hey, we're willing to say that that's statistically significant. There's a trade-off here between controlling false positives and false negatives. Like I said, we're not really eliminating uncertainty. We're just managing and understanding the uncertainty from our tests. So how do we interpret statistical significance? Well, here's some made up numbers, but it sort of shows you the results you might get from a test. We have our version A, our version B. We have some metric we care about. In version A, it's 87.2. And then version B, we see a 0.7 increase in the value of that metric. Then we have something called a p-value, which here is 0.026. The p-value means that the probability of seeing a result at least as extreme as this 0.7 difference that we observe in this test is only 0.026. And because we rely on that 5% value for statistical significance, we would conclude that there is a statistically significant difference between these experiences, and that the reason this product version B is doing better, we conclude that the test treatment product version B is the reason why this metric has increased. Okay. So as we wrap up this more detailed overview of testing, I want to end by saying that statistics helps us reduce and understand error rates and generally make good decisions in the face of uncertainty. We don't eliminate uncertainty, and we don't eliminate the possibility that we might make a mistake. It can feel a little bit uncomfortable. And in particular, there's no way to know whether the results of a specific experiment is a false positive if it comes out as a positive result, or a false negative if it comes out as a negative result. So what we try to do is mix the statistical results with a fair amount of judgment as we think about making decisions. So do the results, and here are some questions that help bring judgment to the interpretation of test results. So do the results align with the hypothesis? Let's go back to that mobile preview example. If we found some big increase in engagement when we expose members to that feature, we actually find that none of our members are interacting with that feature, that might give us pause. So that's sort of getting at, does the metric story hang together? Can we sort of measure the steps through that causal chain from the product intervention to these core metrics that we care about? We also look for supporting or refuting evidence across cells. We might test several variants of that mobile previews experience. They all consistently show a similar response in the metrics. We'll have gives us more reason to believe that we've truly improved or changed member behavior. And finally, do results repeat? If we rerun the experiment, do we get a similar result? So at Netflix, we run a lot of experiments. In fact, test results are expected for most decisions. As a result, we've invested a great deal of resource into an internal platform to support our experimentation program. Call it XP. Blaze is our front-end UI, and some of the materials I've talked about today are from our Intro to Experimentation internal class. And really, this is about democratizing access and contributions to experimentation. So I just want to spend a few minutes here before I wrap up talking about our experimentation platform and the role that my team plays. So our experimentation platform, I think of as a truly interdisciplinary collaboration. It's a collaboration between a bunch of different types of engineer, between data scientists and statisticians. There's a major numerical computing piece that allows us to do statistics on the sizes of tests that we run and the number of tests that we run. And finally, there's a product design and product management piece as we think about our platform as an internal tool, an internal product within the company. And there's three pillars that our platform relies on. The first is trustworthiness. If any data shows up on our platform, we need to ensure that it's reliable and trustworthy so our decision makers can confidently use that data to inform product decisions. Second, we talk a lot on my team about inclusivity. We're serving a lot of different audiences, from executives, product managers, data scientists, engineers who run tests, data scientists who use languages that are different from engineers. We need to be inclusive of all of these disciplines for this to work. And the third is scalability. Again, we run a lot of experiments, many of them very large. And today, for a few minutes, I just want to talk about scalability and how it interacts with this theme of democratization. And here, specifically how we think as a platform team about scaling the scientists that we support, the scientists who actually run experiments, interpret results, and then how we scale decision makers, be they product managers, and be they engineers, and in some cases the scientists themselves. So in scaling the scientists, we've made some very deliberate bets as a platform team, and in particular, we have thought about how to build a modular platform that democratizes contributions and access to different elements. So specifically, we've disentangled this idea, disentangled the platform into these three distinct modules. The first is where you would go to define a new metric that's important for your experiment. The second is where you would go to define the statistical analysis that's required to analyze that metric and experiment. And then the third is where you would go to define visualizations that are necessary to surface the results of that statistical test. And then what's great, and what really links this to the theme of democratization, is that not only can folks contribute to each of these modules, their contributions are then available to everyone. And as a result, many possible analysis workflows are supported. You can kind of just wire these up. Hey, for this test, here are the metrics I need. They're already defined. I want to wire them up to this type of causal model, and then wire the results up to these visualizations. I want that to flow through to both the internal UI as well as a notebook environment that gives me more flexibility. And finally, and this is more on inclusivity, all of this can be done in R and Python, so the language of data science rather than the language of engineering, even though this is a pretty involved engineering system in the background. So scientists can come, they can access the results of their tests both in notebook environments like you're seeing here, and very quickly in just a few lines of code reproduce the same type of visualizations that you actually see on our internal UI, but with more flexibility. Okay, and then briefly, how do we think about scaling decision makers? Well, the first is kind of counterintuitive. We scale decision makers by scaling scientists. So by really emphasizing an efficient and science-centric platform, one of the things we're trying to do is build automation deeper into the workflows of test analysts. So the mental image I have here is that if our analysts at Netflix are doing like run on the hamster wheel type of work, you know, I've got to write some query, I've got to grab this data, I've got to use some package in Python to fit some model, just like super rote stuff. We should be automating that. We should be taking that burden on from the platform and really freeing up the analysts to focus more on creative problem solving, exploratory work to generate hypotheses, research projects, like the super high value work that these data scientists can do. So I really think a big goal of our platform is workflow improvements and workflow automations. So anything that the data scientists need to do more than once, we take on. And second is through UI access. So on the right, I showed that image before. This is the interactive notebook environment that's more targeted at data scientists. Then on the left is our Blaze, our internal UI. And the goal here is to develop accessible and intuitive UIs that allow that present our results and permit for confident decision making for a wide variety of different types of individual, different types of stakeholder. And I think, if I'm being honest here, we're a long way from being finished here. There's a lot of room for improvement in how we're presenting these results. So when I think about democratizing, and this is our third theme, democratizing access and contributions to an experimentation platform to really help us scale, this is kind of the mental image I have. Our platform directly supports scientists who then contribute back to the platform in this positive feedback loop. We also directly support decision makers through our UIs. And then in success, because of these workflow improvements that the platform delivers, we actually allow the scientists to scale their support of the decision makers, often product managers or engineers. So in summary, not quite in summary. So this is our third theme about democratization, how we scale. So our platform level investments allow scientists to contribute directly and empower a variety of decision makers. So in success, no one is ever blocked by the platform. They are enabled by the platform to serve themselves and to contribute back. Okay, so what we've talked about today is decision making and experimentation at Netflix, democratization 3 ways. So the first is how we decide. By using A/B tests, we allow our members to vote with their actions on how to evolve the product experience. Second is what we try. Because we test and because most ideas are not winners, there really is this open marketplace for product innovation ideas, and we see great ideas coming from a whole bunch of different types of people within the business. And the third, how we scale. This is the result of our platform level investments, which allows scientists to contribute directly and really empower that large variety of decision makers. And that is all from me. Thank you for your time and attention.